Hi, I'm Rav from CraftandHue. Today I'm going to be doing some routine maintenance on the Bambu Lab AMS. If anything like me, it's probably something you've never done until an issue crops up, for example a blocked port. Bambu Lab recommends carrying out maintenance every 1 to 2 months or sooner if you're using abrasive materials. It doesn't take long and it can prevent a lot of common feeder issues. In this video I'm going to be walking through the simple maintenance checks, and if you found this helpful, do consider liking the video, and if you're new around here, please subscribe. To start with, make sure the printer and AMS are powered off. Next, remove the 2 middle spools of filament. We're doing this to give ourselves access to the release button at the back, which allows us to disconnect the PTFE tube that runs from the AMS to the printer via the buffer. Next, I'm disconnecting the 6-pin power cable that runs from the printer to the AMS. To do this, press down on the clip to release the connector and pull it out. After that, we're going to do the PTFE tube that runs from the AMS buffer to the AMS. We can remove this by pressing and holding the button on the inside of the AMS to release the tube and gently pull it free. If you haven't already done so, go ahead and remove the remaining 2 spools. With the AMS now clear, I'm taking a look from above to check for any visible damage or debris stuck inside the feeders. Once this is done, I'm going to remove the 3D printed desiccant holders at the front of the AMS. Next, we're going to remove the desiccant trays inside the base. To do this, pull down on the tab and lift upwards in the same motion. Here I'm checking the back of the feeders for any visible signs of damage. I'm inspecting the feeder itself, the support shaft assembly and the PTFE tube, making sure everything looks secure and free from wear or debris. I'm now using the short off-cut filament to test each feeder, just to make sure they're accepting filament correctly. As you can see, port 3 isn't responding as expected, it appears to be locked up. During the initial visual inspection, I didn't see anything obvious jammed inside the feeder, so this is something I'll need to investigate further. With the screws now removed, I can carefully lift the main frame. Before lifting it fully, press in the same tab used earlier for the PTFE tube release that's going to the buffer. This gives us enough clearance to move the frame upwards. Take care here as there are 2 additional ribbon cables attached to the underside of the frame. Lift it gently and avoid putting any strain on those cables. Next, carefully disconnect the 2 cables. Once the cables are disconnected, we can begin inspecting the PTFE tubes for any signs of damage. To remove them, press in the black release ring on the hub and then gently pull the tubes free. There's also a black release ring on the bottom of each feeder. Press that in to release the tube from that side as well. If any of the tubes shows signs of wear, deformation or internal damage, this is the point where we should replace them. Next, we're going to inspect the support shafts by gently spinning them to make sure they rotate freely. While doing this, I'm checking for any signs of damage to the bearings, the drive cog and the plastic supports that hold the spool in place. As you can see, port 4 isn't spinning as smoothly as it should. It looks like it's catching slightly. To remove the support shaft, lift the bearings out of its holder. It's a friction fitting. Remove one side first and then the other and gently roll the shaft out. I'm going to remove all of them so I can give them a clean and make sure the issue I have with port 3 isn't being caused by one of these assemblies. Again, with my off-cut of filament, I'm going to test all the feeders, and as you can see, port 3 is now operating normally. It appears the support shaft was slightly misaligned with the feeder gear, which was preventing it from turning freely and accepting the filament. To reinstate the support shaft, follow the same steps in reverse. Carefully seat the shaft back into place, ensuring the yellow gear inside the feeder is properly aligned with the black gear on the shaft. Make sure the bearings are also pressed down fully into the holder. If not seated correctly, this can lead to feeding errors. Now it's time to reinstall the base and the main frame by lowering into place and reconnecting the 2 cables, making sure they're fully seated and not twisted or under any strain. Reinstalling the desiccant trays and tightening the screws securely. With that done, reconnect the PTFE tube from the buffer back to the AMS, making sure it's fully seated in the fittings. Finally, reconnect the 6-pin power cable between the printer and AMS, pressing it in until it clicks securely into place. With everything reassembled, power the system back on Once it's fully started up, reinstall the filament spools and load them into the AMS. Then run a quick test print to make sure all ports are feeding correctly. In my case, I had a customer order ready to go, so that served as a perfect real-world test, and thankfully everything was running smoothly again. Regular maintenance like this can make a real difference to reliability. If you found this helpful, do give the video a like and consider subscribing for more 3D printing content. Thank you for watching, and I'll see you guys in the next one. Bye.